Today we will look into factoring trinomials with a leading coefficient that is not 1. Earlier we learned how to factor quadratic trinomials when leading coefficient is 1. And we also learned a trick. If the leading coefficient is not 1, we could use the greatest common factor and factor out that coefficient to make the leading coefficient 1. It turns out that in some trinomials, even if we try to factor the greatest common factor, we may still end up with a leading coefficient that's not 1. And today we will be factoring those trinomials whose leading coefficients are not equal to 1. Here's our vocab. The trinomial form we are working on is ax squared plus bx plus c. And we will be focusing on the grouping method. There are other methods available. We will cover only one of these on our video, and we can mention the other ones during the class. Here are our steps. This is a multi-step process, and go ahead and write your steps for each number, and then we're going to go through these steps with our first example. We're going to follow these steps one at a time and solve our examples, solve our quadratic trinomials when leading coefficient is not equal to 1. Here's our first example. In order to factor this trinomial, I can try to factor out the greatest common factor first, and 8 is not divisible by 10 or 3, so factoring out the GCF is not going to help us. And in this case, we are going to start on our process, and step 1 is multiply the leading coefficient by the constant. That means leading coefficient is 8, constant is 3, multiply them together. 8 times 3 is equal to 24. After multiplying them together, then we are going to find factors of 24 that could add up to the middle term. Our middle term is 10. Factors of 24 that could add up to 10 are 6 and 4. So I know this is going to be 6 times 4. Those numbers tell us how to split this middle term. We're going to split the middle term into a 6x and a 4x. We got these 6 and 4 from the factors of 24. After splitting the middle term, we are going to copy down the first term and the last term. Now we are going to try to group the first two and the next two. This is the reason why we call this a grouping method. In the first group, we are going to identify our greatest common factor, and we're going to factor out the greatest common factor. In the first group, 2 is common as far as numbers, and x is common. So I'm going to factor out a 2x from the first group. On the second group, there is nothing common. So I'm just going to factor out a 1. When we factor out the 2x from the first group of binomial, we're going to have 2x. That's going to leave us a 4x. 8x squared divided by 2x is 4x. And 6x divided by 2x is 3. On the second group, if I factor out a 1, then we are going to have 4x plus 3 again. As you can see, we have a matching binomial. We are going to factor this common binomial, matching binomial, one more time, and we will write that up front as 4x plus 3. Factor that out one more time, and if you divide out a 4x plus 3 from the first multiplication, then we will have 2x left. If I divide out the 4x3 from the second group of multiplication, right here, then we are going to have a positive 1 left. And this will be the result of our factoring from the trinomial. We can do a check step by distributing this back again. Here's my check step. In the check step, we will distribute the first term to the next two, distribute the second term to the next two, and After we do the distribution, we combine like terms, and as you can see, we got back to the original problem, so our factoring was correct. Here is our next example. First, check to see if there is any greatest common factor. Can we get rid of the 3 by factoring out 3 from everyone? 3 doesn't divide negative 17 nor 10, so we won't be able to factor out the 3. So we know that we're going to have to go through this process. First, multiply first number with the last number. 3 times 10 is 30. After finding that number, we're going to find factors of 30 that could add up to negative 17. It's going to be negative 2 and negative 15. Those are the numbers that we will split the middle term into. We are going to have a negative 2x and negative 15x. We are going to copy down the first term and the last term. We separated the middle term into 2 factors. Now we're going to use the grouping step. The reason why we call this a grouping method, because we group the first 2 and the next 2. On the first 2, greatest common factor is x. On the next 2, greatest common factor is 5. However, because our leading coefficient on the next 2 is negative, we are going to factor out a negative 5. Regardless of negative is common on both of them or not, we are still going to factor out a negative because leading coefficient is negative. So if I factor out an x from the first group, we should have 3x minus 2 left. If I factor out a negative 5 from the second group, we will have 3x minus 2 left. As you can see, we have matching binomials. All we have to do is to write the matching binomials once, and then if you take out the matching binomial from the first group, you have x left. If you take out the matching binomial from the second group, you have minus 5 left. Here's our check step. Here's your first try. Here's my next example. This time I have a trinomial where it looks like it's difference of 2 squares. The question is, can I write this as difference of 2 squares? If I can see that the first term squared and second term squared is difference of 2 squares, then I can write this difference of 2 squares as 2x minus 9 and 2x plus 9. We could only do this if we could recognize difference of 2 squares. Now, this is not the only way of solving this. We could rewrite this as a trinomial, 4x squared plus 0x minus 81. And we will try to go through our process, and we will multiply first number and last number. That would be 4 times 81 is equal to 324. We will find factors of 324. That's going to be negative. That's negative 81. Factors of negative 324 that adds up to 0 is 18 and negative 18. That's what we will split the middle term into. 4x squared positive 18x minus 18x minus 81. Now we will do our groupings. First group, second group. In the first group we have x common and 2 common. On the second group we have negative leading coefficient and we have 9 common. Let's factor out the greatest common factor from each group. Here's my 2x up front. You will have 2x plus 9 And if I factor out negative 9 on the second one, I should get 2x plus 9 again. Now we can factor out the common binomial one last time. 2x plus 9 times, if I take out 2x plus 9, from the first term we will have 2x left. From the second term we will have negative 9 left. As you can see, we got to the same answer in both methods. One is a little quicker than the other one. You could choose to do whichever method you like the best. Here's your U-try. You can solve this with either of the methods. Here's my last example. We are going to multiply first term and last term. 9 times 4 is 36. We're going to factor 36 into two parts where it could add up to 12. That's positive 6 and positive 6. So that's how I'm going to split the middle into a 6x and another 6x. My first term and last term are staying as is. We're going to try to group first two and second two, and we will factor out the greatest common factor. In the first two, I see 3x common. On the second two, I have 2 common. If I factor out a 3x from the first group, you will have 3x plus 2. If you factor out a 2 on the second group, you should have 3x plus 2. We're going to factor out the group common binomial one more time. 3x plus 2 factored out. You will have 3x left from the first one and 2 left from the second one. It turns out that we have the same term on each binomial, so this is writing 3x plus 2 parenthesis squared. Here's your last U-try. Please go back to our steps and try to find the correct factors. Go step by step. That's pretty much it. During the class, we will be focusing on more detailed questions.